Hey, hi YouTube, how are you? I hope you all guys are doing great. In this video, we are going to explore joins, and definitely this video is going to be a long video, but trust me, it will be worth it to spend a long time on joins because join is a really important topic. Because in a real use case, you will never see a single table. There will be multiple tables, and you have to play with it. And I think instead of breaking these joins into multiple videos, and maybe I can also create 10 to 20 videos on just joins. Instead, I was thinking to make one video and I can pour everything of joins in this part. Okay, so that at least at the beginner or intermediate level, you should know the joins. Okay, so let's start the joins, and definitely I have some predefined tables here. Also in MySQL query, also I have created this table. So once we will move to the practical part, we can see this both the tables because it will save your time only. Okay, so I have created two tables. First one is employee, so it will be having employee ID, full name, department ID, salary, and the second table is department. Okay, and this is basically here it is primary key, and here this is the primary key, and it is the foreign key. So if you don't know about keys, I have already created a video. So basically, just to give you overview, foreign key is basically it connects the two tables. So this table, this column will refer to the primary key of another table, and here you can see this is the common column. So they such that the two or multiple tables can connect with each other. Okay, let me just remove it for this moment. Okay, so let's start with joins. So what actually joins are? It is used to combine multiple, or you can say to combine the data from multiple tables. Okay, so it is used to combine data from multiple tables. Okay, so this is the first thing which you should know about joins. Second is to retrieve related data stored across table, because I already told you that the data is stored across multiple tables, maybe 4 to 5 tables or more than 4 to 5 tables are there, and you have to combine them, and whatever data you want only you can get after joining the table. For example, just to give you an example, if you want to find that in which department John Doe works. So definitely, if you see this 01, so you will go here. Okay, 0101 is HR. So you can say John Doe works at HR department. Okay, and where do I get this data? It's basically generated by ChatGPT, and I think you should use ChatGPT as much as you can for your learning purpose. Okay, so to retrieve related data stored across table. Okay, so these are two things which you should know about joins, and definitely it's not more about theory, it's more about practical. Okay, so there are multiple types of joins. Okay, this much is enough that we have multiple tables and it is used to combine the data from multiple tables. If you want to retrieve data from which is stored across the tables, you if you want to extract it, you can use these joins. So first type of join is inner join. Okay, so first type of join is inner join. What actually inner join means? So it's simple. It returns matching rows from both the table. Okay. It returns matching row, or you can say matching rows from both tables. Okay. So we are going to deal with this table. So let me just bring both this table here. That's why I have created it here so that we can easily duplicate it and we can use it. Oh, what happened? I don't know. Maybe I have to take it one by one. So let me first duplicate this. This is the first table we want to experiment or we want to learn. So all the joins examples will be regarding these two tables only. Okay, so that's why I have created it and it's going to be useful. Okay, so let's duplicate it. A good feature of iPad, I think, which is really helpful. Okay, so This is the inner join. Oh my God. This is, what is this? This is ID or this is employee ID? Yeah, it was employee ID. So let me just write it like this. Okay. So inner join returns matching rows from both the table. Okay. What happened? I don't know. I'm unable to drag. Okay. So it returns matching row from all the tables. Okay. From both the, currently we have two tables. So from both the tables. So if you see how many matching rows we have, okay, so you can directly we can say that one matching row is this 101, 101. We also have 102, 102. We also have 101, 101. We have also have 101, 101. We have 103, 103. But null and 104 are not matching. So we will not include that row. Okay. But how actually this works? Like what actually the mechanism behind this inner join? How actually SQL knows which are the common tables. Okay, so it does a Cartesian product, and what actually Cartesian product means, that Cartesian product means we have to, this first row will be combined with all the four rows with the new table or the next table. Then the second row will be combined with all the records of second table of the second table. What I want to say is, when we will combine, okay, let's combine both the table. If we will combine both the table, the first column will be employee ID, second will be full name, third will be department ID, and this department ID is from employee table. Then we also have salary. We also have department ID from, it is from department table. This employee ID is from department table. Then we also have department name. Okay. So first row we will take like this. So first row is 1 John Doe, 101 and 50. So this is really an important exercise because we should know how actually the inner join is working behind the scenes. Okay. So let's duplicate. So this will be our first row. 1 John Doe. Uh, Let me just erase it a bit. It will be much better. 1 John Doe, and department ID is 101 and salary is 5,000. So it will first combine with this, then this, then this, then this. So it is a Cartesian product. Each row will be mapped to each row of another table. Okay. So now the salary for John Doe is 5,000. Now the department ID is 101 and department name is HR. Now the same row, okay, the same row will also be combined with all the other rows of the department table. So sorry. So let me just duplicate it. And I think we have to make four duplicates like this because four times we are going to combine it. So this same row will be also combined with 102 IT, which is the second row of department table, 103 marketing department, which is the third row of this department table, and also the fourth row, which is 101 for finance department. Okay, so in this way, you can see that first row has been combined with all the rows of second table. Okay. Now we have to also do for other rows. Okay. Okay. So now we have combined the first row of first table with all the rows of second table. Now in the same manner, we have to also combine the second row of first column, first table, which is 2 Jan Smith 102 6,000, and we have to use all the departments, means all the row of second table. I think now it's a redundant work, but I think this exercise is really important, so that's why I'm doing it. I'm not just wasting your time. Okay, now we have to just do the copy paste. So let's make one more duplicate, and let's one more duplicate here. So here you can see we have created for two rows. Okay, now third row will be Alice Brown. Okay, so third one is, sorry, it's third is Alice Brown, and it's 101, I guess, isn't it? And 550, 500. Sorry, 500. So again, this third row will be paired up with all the other rows of the second column. Okay, it duplicate, pull, duplicate. Yeah. Now let's see for the fourth row. Fourth row is about Bob White 103. Fourth row is Bob White 103, and it's around 4500. Again, this row, which is the fourth row, will combine with all the rows of second table. Okay, will be some like this, it like this, again, do it, duplicate it like this. Cool. Now we have the fifth row, which is I think about Emma Clark, null 4000. So fifth is Emma Clark 104, 104. Sorry, no. Emma Clark is assigned as null because she doesn't have any department. So it is null, and 4000 is the salary. And again, we have to combine with all the columns of the second, all the rows of the second column. And we have to also duplicate it two times. So first is this, then we have to duplicate one more time. So it will, okay. So this is how the table, or we can say the Cartesian product, will look like for both the tables. Okay, let me zoom out a bit. So Cartesian product of both this table will look like this. So what I told you at the initial stage, that we have to return all the matching rows, and on which basis we match it, we match it on the basis of department id. So we will only select the rows where the department id, where this column and this column value matches. So here you can say 10101 is matching, so this will be selected. This will be not selected. Why? Because 101 and 102, 101, 103, 101, 104, 102, 101. So this will be also selected. 102, 102. This will be not selected. This will be not selected. This will be getting selected because the employee, sorry, the department ID is common. So this will be also not selected. Not, not, no, no. This will be getting selected. No, no. So only we will get four rows, which will be John Doe 101, and so this is how it will look like. John Doe 101, it will be paired up with this row. Then Jane Smith 102 and 102 will be paired up. Then Alice Brown 101 and Alice Brown 101, 101. So Alice Brown 101 will pair with this row, and Bob White 103 will be paired with this row. So we will get only four rows out of it. Is it clear? So this is how the things work behind the scene. Okay, it's simple to tell that okay, it returns matching rows from both the table, which are the common rows. Okay, because 101 is common, 102 is common, 101 again is common, and 103 is common. So it will return this row. But actually it makes a Cartesian product, and then it's able to see how, which columns or which rows are matching, where the department ID of employee and department ID from department table is common. Okay, so it will give four rows. Okay, is it clear? So what it will return? Okay, maybe uh, maybe let's suppose someone given you a task that please return that the full name, the full name, and in which department they are working. Okay, because so how you can find This by using inner join, because we want only the common rows, not any other rows. Okay. So what are the common rows? First one was John Doe. So John Doe, and he was working in HR department. Second common row was Jan Smith. So Jan Smith is 102, which is IT department. Similarly, Alice Brown 101 from HR department. Then Bob White 103. You can see 103 is marketing department. So it will be from marketing department. Is it clear? So this will be output if someone is asking you that can you give me the name of the employees and in which department they are working. So in this case, you can use inner join. Okay. Now, how the query will look like for this inner join, or how we write a query for inner join again. Okay. So what we want to show. So we know that in select we write what are the columns that we want to show. So we want to show full name and department name. And full name is from and employee table and department name is from department table. Okay. So now it's not like we have all the columns in a single table. We have columns in multiple tables. So it will be like select. We want to first show the full name, which is from employee table. Table name employee dot. What is the column name? Column name is full name. Is it clear? Let me raise it. Then what is the second column that we want to show? It is department name. And where is this department name? It is in the department table. So it is department dot department name. Okay. From which is the primary table? Primary table is employee because here we have foreign key and so on. So from EMP. Now, which kind of join we want to perform? We want to perform inner join. Inner join. Which table is going to be joined? Currently, we are just playing with two tables. We can also connect multiple tables. So, first of all, let's see for two tables, and we can have a separate video for multiple tables where we can join. But the syntax remains same. Okay. Inner join. Now that we have another table which is department. Okay. So employee table is being joined with department table, and employee table is the left table, or you can say the primary table, and we are using another table which is department. Okay. Now on which column we want to join? So we have seen that there is this is the foreign key and this is the primary key. So foreign key is a column which connects to the primary key of another table. So we have this is the common table, you can say. Okay, common table on which we are performing the join. So from the employee table, e sorry emp dot department id, because department id is common, so we have to tell that okay, this department id is from employee table where it is equals to department dot department id. So this department id is from the department table, this department id is from the employee table. We have to segregate, and we have to also tell okay, this full name is for employee table, this department name is from department table. That's why we are writing like this. Now if you will run this query, this will give you this output. So in this scenario we have to use kind of inner join. Okay, now let's see the practical of it so that you can get a better idea. Okay, so I have already created a table for you so that it will be easy for you to quickly go through all this thing. So we have created a table called department, which is having department ID, which is integer and it's the primary key of that table. We have also department name as a column, which is varchar and the limit is 10. Then we have also created another table, which is employee. The columns are employee ID, int primary key, full name is varchar, department ID is int, which is also going to be foreign key of this table. Then salary decimal 10 comma 2. So we also, this is how we uh, assign or we create a foreign key. So in the foreign key or the in the keys video, I have told you that in some of the video I will show how we create a foreign key. So foreign key, and in this table, which is foreign key, it is department ID. Now it references to another table which is department, and to which column? To department ID of that department table. Okay, so this is how we create a foreign key. Then I have also inserted data that we have already seen in previous videos. So I am inserting multiple rows. Here also I am inserting multiple rows. So here we can see, if you see how many data we have in department table, these are all the data. We have also some data from employee table. So there you can see we have also one null value. Okay, this is the same thing which I already shown you here. Okay, I have just created this data in a table. Okay, cool. You can also describe it to see how the table schema looks like. So here you can see that employee ID is integer, null value is no because it's a primary key, full name varchar yes, null value. There can be null value because we haven't mentioned it, not null. Okay, department ID is int, and we have multiple means multiple. It means that we one value can repeat multiple times. Okay, so here you can see, if you go to here and just go here and let's see. Oh, sorry. We can't do it because we have to just see the rows. Okay. So here you can see that 101 is repeating two times. So one value can repeat multiple times. So that's why it is showing at MUL, multiple. Okay. So I think you have already learned another keys. Okay. We have also seen this in keys video. I think I haven't touched multiple keys, but this is a very simple thing. Okay. So now let's see the inner join, okay? Or maybe the question is, let's suppose you want to show the employee name with their department name, okay? Department name. Now we have two different tables. One is having all the employee name, and second one is having the department name. So we have to do inner join, okay? So we have to do inner join because we have to find the common rows, okay? So let's do it. Select. So first we have to show the full name, which is from employee table. Then we have to also show the department name, which is from the department table, department dot department underscore name. Cool. Then we say that from our primary table, which is employee. Then we have to write the join name, which is inner join, and the table is department, which is our secondary table or second table, or you can also say that this is left table, this is right table. Okay. Um, on so on which we want to join. So from employee table, we are looking at department ID equals to from department table. Again, it's department underscore ID. So I think that's it. We have already seen in the whiteboard also this part. So if you're honest, so this is what John Doe is from HR department, Alice Brown is from HR department, Jan Smith is on from IT department, and Bob White is from marketing department. And I think we have also seen this here, this output. And I think this much is enough in the inner join. And this Cartesian product is really important to understand how the thing works, because everyone knows that we have to find the common rows, and it's very easy that you have to just look what are the common rows and you can easily find it. But how actually the things work behind the scene? It creates a Cartesian product. Okay, this is a basic mechanism which you should know. I know it is more kind of optimized, but this is how the things looks like. Okay, so if we say that if we want to represent it in some kind of Venn diagram, so how it will look like for inner join, let's suppose we have this left table, we have this right table, we just want the common rows. So this area, the common rows, let's suppose this is our left table. In this case, our left table was employee. And what was our right table? Department. So in this case, the right table is department. We have to just find the common rows. So if you want to understand through Venn diagram, this is the common rows. Okay, so I think that much information is enough for inner join. Now we can move to our next join, which is left join. Okay, let's move to left join. Left join. Okay, now what actually left join does? Left join actually allows all rows from left table, whether it is common or not, it doesn't matter. And from right table, it only allows the matching rows. Okay, so let me write it somewhere. Allow all rows from left table, matching rows. Okay, only matching rows from right table because it is left. So it will uh, allow all the rows from left table and only the matching rows from the right table. Okay, and if there is no matching rows, then it will fill with null. If no matching rows, it will fill no matching rows, fill with null. Okay, we will see again each and everything. We will bisect everything in with examples so that you will understand each and everything. Okay, okay. Now let's take the same example. Okay, so just get a bit zoomed out. Let me take this again. Duplicate is not happening correctly. Okay, let me duplicate this first. Duplicate. Where it gone? So this is our first table. Duplicate. This is our second table. So we are only considering these two tables for understanding all the joins. Okay, so that it should be uniform. Now we have seen here that in left join we have to come take all the columns. Okay, and on the right only the matching rows. Okay, again the task is same. Okay, that you have to find the full name and the department name, but now we are going to use left join. Okay, so again we are going to show only two columns, full name and department name. Okay, the only difference is now we are using left join, and let's see what will be the results. So from left table, we have to take everything. So full name is coming from left table. So we will take everything. John Doe, Jan Smith, Alice Brown, Bob White, Emma Clark. But from right table, we will only take the common. Okay. So if you see here, 101 is common. So it will be filled with HR. Here you can see 102 is common, so it will be filled with IT. Again, here you can see that 101 is common, so it will be filled with HR. 103, it is also common, so we will fill it with marketing department. Okay, but now here you can see that null is not common, so it will be filled with null. Okay, it will be filled with null. So that's the point, that we have to first allow all the rows from left table. So we have taken all the rows from left table. Then allow matching rows. So we have only allowed matching rows from the right table. If no matching found, fill with null. So there is no matching for Emma Clark, means null is not any common value. So we fill it with null only. Okay, simple. Now I think it's the most simplest one. Okay, so how the query will look like, let's see. Very simple. Select what two columns we have to show. Full name, where the full name is coming, it is coming from employee table underscore full name. Then we have to show department name, from which table it is coming, it is coming from department table. From which is the left table is employee. which is the right table, and which kind of join we want to perform. It is inner join? No, it's left join. So left join department. So this is our left table, this is our right table. Okay, on, which is the common point, employee dot department id equals to department dot department id. As simple as that. Okay, so now let's run. Okay, now let's write the query for it, and let's we want to perform for the same question we have to perform left join. Okay, so select employee dot full name, department dot department name from employee left join, it is department on, employee dot department id equals to sorry, it's department dot department id. So now we are doing some kind of left join. Cool. So John Doe is HR, Jen Smith is working on IT department, Alice Brown is working on HR department, Bob White is working on marketing department, and Emma Clark is working on, no. There is a null department. Null department means no department has been assigned to Emma Clark. Now, if I change this order, let's suppose I kept it department and I kept it as employee. Now, what will happen? Just pause this video and let me know in the comment section what you have understood. And I think you have already thought. Let me run it. So now here you can see the null has been shifted here. Why? Because now department is the left column and every row of department table will be taken. Okay, and only the matching rows from right table will be taken, which is employee. Okay, uh, let me explain you. Okay, so if we do kind of, if we make this as department, maybe if we shift it, like if we make department as our left column and employee as our right column, and if we are doing a left join, so all this row like HR, IT, marketing, finance will be there, but from right table, now our employee has become right table, so only the matching rows will be there. So if you see for 104 there will be no matching rows because there is no 104 in the employee table, so it will fill the finance with as null. No employee is working at the finance department. So here you can see no employee is working at the finance department. If you feel a bit confused, just go through it once again. You can revise this part, or you can also like think of your own what is happening and what the things are going on. Okay, because it's not like everything I should not spoon feed to you. Okay, now let's see right join. Okay. Okay, so let me just quickly go through it. So what actually right join is, it is just the opposite of left join. In right join, what we have to do, all the rows from the right table will be included, and only the common rows from left table will be included. And if no match found, we will make it as null. Okay, and I have just copy paste the table. Okay, that we are going to play with it. Okay, simple. Okay, I forgot to actually change the screen. Okay, now, these two columns we have to include. First one is full name and second one is the department name. Okay, cool. Is it fine? Now, we have to include every row from the right table. So, HR, IT, marketing, finance, everything will be included. Okay, so let's do it. So, if you take the full name, maybe just take the department name, I guess, or maybe let's take first, which is the common row in both the tables. So if you take full name, John Doe is 101, 101. So it's common. So John Doe and department name is HR. Is Jane Smith 102 is common? Yeah, it is common. So Jane Smith is working on IT department. Alice Brown 101, is it common? Yeah. Alice Brown is working on HR department. Then Bob White is 103, 103. So Bob White is working on marketing department. Cool. Now, Emma Clark will be included or no? Pause the video and think. It will be not included. Why? Because only the matching rows from left table, only the matching rows from the left table will be taken. And this is our left table and this is our right table. So Emma Clark, which is null, this is not matching. Null is not matching. Null is not there. Okay. So Emma Clark will be not there. But we have to include each and every row from the right table. So department name, which is finance, will be also there. And if we don't find anything, if no match is found, we fill it with null. So this is how it will look like. Okay. And I think the query is very simple, the same as left join. So it will be select. We have to show two columns. One is employee name, which is from employee table. Sorry, not employee name, it's full name, isn't it? Full name from employee table. We have to also show the department name, which is from the department table, and we also which is from, so which is the left table. So left table is employee, and which is the right table. And what we have to do, we have to do right join and department on emp dot department id equals to emp, not emp, department dot department id. As simple as that. This will be our right join. Can you see a thing that if you see both the things, left join and right join, okay, now um, it's like this is the same query, okay. If I will write it like this, okay, this will be the same query. Everything will be common. Only if I write it like this, from department left join employee. So can I say this will become our right join? Because here also, see, we have to include everything from the department. Sorry, we have to include everything from the left table, which is department table. And we have to only include the common elements from the employee table. And this is also what we are doing. We are taking everything from the department table, and we are only taking the common elements from employee table. So if you just reverse the left table and right table, and if you just use, even if you just use left join, it's enough that you can prove both the things, left join and right join. Let me show you. Okay, maybe what you can do is see. Just wait. Okay, so this was our left join example. Okay, what I want to say is, if we make it like this, department, now department will be our left table and employee will be our right table. And if we are doing a left join, it means that every row from department will be included and only the common rows from employee will be there. Okay, so let me run it. So here you can see we got John Doe HR, Alice Brown HR, Jen Smith IT, Bob White marketing, and in finance department none of the employees work. Now, what we have already now discussed, right join. Okay, so let me see the right join. So it was like select employee, sorry, employee dot full name, and we have also department dot department underscore name. Our left table was employee, and it was right join. So right join, and the right table was department table on employee dot department underscore id equals to department dot department underscore id. And just see this output, and I am printing this output again. This is the right join output. So see, there is no difference. Okay, John Doe is working on HR department, Jen Smith is working on IT department, Alice Brown is working on HR department, Bob White is working on marketing department, and in finance department, none of them is working. Okay. And if I also run this will be also the same one. Okay. So that's the thing. Because see, here what we are doing, we have to include everything from department table and only the matching rows from employee table because it is a left join. It is a right join, but here also we are doing the same. Include everything from the department table, but only include the matching rows from the employee table because this is a right join. But if you change the table positioning left and right, then both the joins become the same. Okay. I hope you are getting it. If you feel a bit confused, then just erase these things from your brain. Just go with the basic flow, left join and right join. But if I, whatever I told you, to interchange the tables, if this makes sense, it will be much better. Okay. So this were some joins, and what we can do is next is like our full outer join. Okay. So let me go to whiteboard again because previously I forgot to switch to the whiteboard. Okay, so we have full outer join. Okay, there is nothing like full join. Okay, it's only full outer join. Okay, don't get confused. Uh, it will like all rows from both table. All rows from both table we have to take. Okay. Um, and rows without a match will contain null. The same thing. Rows without a match will contain null. Okay, simple. So we have this. Yeah, I can copy it from here only. This is where we are going to. We are just taking this example every time. Let me just here. Okay, so this doesn't looks good. Doesn't looks good. Okay, so let me bring it from here only. Okay, let me take it. Let me take. Let me try to take both at the same time. Why this is not happening, I don't know. Okay, let me take it one by one, duplicate, and let me take it here. Here is our full outer join. A bit mess. Okay, finally, finally. Okay, now we want this table also to be here. Let me drag it a bit. Let me drag it a bit. Okay, so these are the two tables in which we have to deal. Okay, cool. So what full outer join means all rows from both the table. Okay. And if there is no match, it will contain null. Simple. Okay. So again we have to show the full name, and it's not compulsory that you have to just show the full name and department name. It's not like that. Okay. You can show any column. Just for the simplicity, I'm taking this column so that you can have a better understanding. Now we have to take each and every column, okay, each and every row. So first row will be John Doe, then Jane Smith, Alice Brown, Bob White, Emma Clark. John Doe is working 101 he's working on HR. Jane Smith 102 it's working on IT department. Alice Brown 101 it is working on HR department. Bob White 103 it's working on marketing department. Then Emma Clark is null, so he's not working on any department, so it will be null. But we have to also take the finance department because from both the tables we have to take all the rows. But this finance department is 104 and 104 is not in the employee table. So the full name will be null because whenever there is no match, it will contain null value. As simple as that. This out. Okay, so we have seen the output for the full outer join, or yeah. So. mm Here you can see that if you can notice something that if you go to left join,
Here you can see we have five full name: JD, JS, AB, PW, EC, and we're having null. Okay, so and here if you can see that here in the output we were having JD, JS, AB, BW, and null, and we are also having finance department, which was not here. But here it's kind of union of both the things. Okay, if you take the union of both the tables, the output of left join and the output of right join, you will get this table, isn't it? So it's like the union of left join and the right join will give you the left, or you can say the full outer join. Okay, basically SQL, it doesn't directly support full outer join. Like it, the MySQL lacks native support for the full outer join. However, we can simulate full outer join using a combination of left join and right join along with union operator. Okay, so how it will look like, the code which is for left join, we will write it here, and we will add a union operator, and the code for right join will be here, and this will be giving you the output for full outer join. So the left join, this part returns all the rows from the employee table, including unmatched rows from department, nulls for the missing department, which we have already seen the left join. And the right join part will return all the rows from department table, including unmatched rows from employees, nulls for the missing employees. And union will combine results from both join, and it will and remove duplicates automatically. Okay. So what I want to say is, like, let me show it in the code. So simply what you have to do is just take the left join, just remove this semicolon because we don't want semicolon here, as we don't want to end this query here. Then we are taking the right join. Okay, and if you will run this, okay, so let's run this. Now you will get the full outer join. Okay, let me write it here: full outer join. Okay, so this is kind of combination of left, not combination, or you can say union of left join and right join is basically full outer join. Okay, so also let me show it on Venn diagram. Maybe it will be much clear to you. So this was left join and this is right join. So left table, right table. So how this will look like? Let me move to that screen. So here you can see everything from right table will be included and also the common elements. And in full outer join, everything will be left table, right table, and everything will be included. So don't you think it's kind of union of both this thing, this one and this one? If you do a union of both this thing, you will get this thing. So that's why we don't have to write like in the query, we don't have to like write like full outer join. It doesn't natively, MySQL doesn't support it, but smartly we can extract it. Okay, so this was about full outer join. But before, okay, we have some more joins, but before moving to more joins, I want to give you some information that is really, really important, because in some interviews they ask you about left outer join, but people get confused. What is left outer join? I have just learned about left join. So there is nothing like left outer join. It's just another name for left join. So left join and left outer join both are same. Similarly, for right join, we have another name called as right outer join. So if someone asks you in an interview, can you explain right outer join? Then don't get confused. You have to just explain right join only. Same if you have full outer join. If someone asks you like, tell me full join or maybe outer join kind of thing, don't get confused. So full outer join, full join, these all are the synonyms. But generally they ask like full outer join, right join and left join. But sometimes just to check you how good you are, just they ask like, tell me about left outer join. Then you get confused. Okay, I have learned left join. What is left outer join? And maybe you start saying something else. Okay, so both are kind of same. Okay, okay, so we have seen the most important four joins. Okay, so let me summarize it a bit. Okay, so first one was our inner join. Okay, so we have seen inner join. When we have to use this inner join, when only need matching rows. Okay, when we just need the matching rows, we use inner join. If we represent it somewhere here, if it is your left table, it is your, let's suppose this is your right table, only the common rows will be there. Okay, if we have, when we have to use left join, when we have to, when all records from left is needed, even there is, even if no match. Okay, let's suppose we want, there is a scenario where we want each and every row from left. We don't want to lose any records from left table, even if it is not matching. Okay, so how it will look in Venn diagram? So left table and right table. Okay, so it will include each and everything from the left table, but it also includes the common elements of right table. Okay, but the main thing is we don't want to lose any records from the left table. Then we have right join. So right join was when all records from, when all records from it was left, I forgot, when all records from right, even if no match. Okay, if even if there is no match and we want everything from the right table, we will use right join. Okay, and so it is our left table, this is our right table, and we, if we want everything from the right table, this will look like this. Then we also have full outer join, full outer join, full join, or whatever you say. So you need, when you need all data from tables, all the data from the tables. If you need all the data from the tables, then you can use full outer join. And the Venn diagram of it will look something like this, that we want each and every rows from both the tables. Okay, so this was the summary of the four rows that we have studied: inner join, left join, right join, and full outer join. These are the most important joins. Okay, but there are some more joins also, like one of them is self join, and we also have cross join. Okay, which we will be seeing next. So now we are going to see self join and cross join. Um, Cross join is kind of same, like same as the Cartesian product that we have seen in the first join, that was inner join. But self join is also easy, but it's sometimes a bit confusing. Even the folks, the mates which who are at, even at job, they find it a bit confusing sometimes. So that's why I want some of your focus in this self join. Um, it's okay if you will not focus on cross join, but in self join, I need some time, some important time, so that you can focus in this self join. Okay. So by the name, it is clear in self join, the table will join with itself. Table joined with itself. Okay. Now let's take an example. So we have a employee table. Okay, and we have multiple columns like employee ID, full name, um, manager ID, and also salary. Okay, employee ID like 1, 2, 3, 4, 5. Full name, the same name, um, John Doe and such name. Alice Brown, such name. Emma Clark. I am taking. Manager IDs. Let's suppose we have null 1, 1, 2, 3. Salary can be anything: 5K, 6K, 7K, 8K, 9K. Okay. Now let's suppose you have this table and someone given you a task, that we have a task here to find name of employees and their manager. Okay, so how the output will look like? We have to give the employee name and also manager name. So let's suppose employee name is JD, whose manager is no one. JS, who's the manager of JS with manager ID 1, or we can say employee ID is 1. Employee ID and manager ID are same. So who is having one employee ID? JD. So JD will be the manager of JS. AB. AB's manager ID is 1 and one employee ID is for JD. So it will be JD. Then we have BW, who the ID or the employee ID 2 is the manager of BW. So 2 is JS. So it would be J. Then EC 3, whose employee ID is 3, AB. Will be A. So this will be our final output, and this will be achieved by self join. And there is nothing like self join. Okay, like um, I mean to say, like you were saying, left join, right join, inner join, cross join. There are specific keywords, but there is no keyword for self join. Okay, with the help of left join, outer join, inner join, we have to construct a query for self join. Okay, so this is what the output of self join will look like. Now let me write and query for it, and then we will see. I know where you will fall, so I will help you at that point. Okay, so the query will be select. So we are going to show emp dot full name as, so we want to show this column as employee, which is we are giving as some alias mgr dot full name as manager. From, so we are going to use, we just have one table employee, but we are dividing that table into two tables. One will be employee, and we are going to have left join, and on the table employee, but we are giving alias to this table, which is manager. And on which basis we are going to make it? Emp, this newly constructed table emp dot manager id equals to not emp, it will manager dot employee id. This will be the inner join, sorry, self join query to achieve this. Okay, and I know you haven't understood anything, I know. Okay, so I will make it much more simpler for you. Drag it somewhere here. Okay, so now we know that in self join or any kind of join, not self join, we have seen two or more than two tables. Currently we just have seen two tables, so it is much easier for us to visualize it when we have two tables. So I will divide this major table into two tables. One table will be called as for employee and second will be called as for manager. Okay, parent will be the same table only, but for this, how actually this thing works to make you understand, I am dividing it into two tables. Okay, one will be employee and one will be manager. The content of the table will be same because we just have one table only. Okay, it will be always same. So let me make duplicate first. Let me drag it a bit. Which kind of problems? Select it. Okay, so we will be having same column. One of the table will be employee, another table will be as manager. So let me add a line here so it will be easier for you to differentiate. The only difference is we have to find a way so that we can differentiate the columns because both the table has same column, which is employee ID. So we will call it as emp dot employee id, emp dot full name. So it's like table dot column name, emp dot manager id dot salary, and here mgr dot employee id, mgr dot full name, mgr dot manager id, mgr dot salary. As simple. Okay. So now we have two different tables, and we can perform any join, left join, inner join, outer join, depending upon the use case. Okay. For this, here you can see we need all the employees name, and the manager can be null. Okay, it's not a problem, but we need the name of all employees with their manager. So definitely it should be kind of inner join. Sorry, it should be kind of left join. Why? Because this is our left join, left table, which is named as emp, and this is our right table, which is named as mgr. So we need all the employees name, and where we can find the employees name? In the employee table. So we need all the records of the left table or employee table. That's why we can do left join. Okay. Now what will be the connecting link between both the tables? I think this one, because if you want to find who is the manager of JD, then you will see the, or maybe let's take AB example. Who is the manager of AB? You will see, okay, manager ID is 1. Now I will have to look that whose employee ID is 1, which you can find it here. Okay, 1 is of JD. That's why the connecting link between both the tables is this. And focus that we don't have two tables. Okay, we just have only one table. Okay, this is the main table. This is just for your proper visualization. I have made it. Okay, cool. So now let's write the query. So what are the two tables we want to show? So definitely we want to show this table, sorry, this column, and we want to show this column. So let's write it. Select employee dot full name, and we also want to show manager dot full name. Now if you don't want to show as this column name, you can also use this, but it doesn't looks good if there is a column name whose column name is emp dot full name. It doesn't looks good, so that's why we give it at alias. So this column we have to show it as employee as a temporary solution, and this will be as a manager, or you can say employee name manager. Okay. Now you will ask me, where does this emp and mgr come? We just have a table called employee. How this mgr and emp came? So definitely it's a valid question, but if you have followed my series perfectly, then you should be knowing that a SQL query doesn't start with select. It doesn't start with select. The syntax starts with select, but the execution starts from. So that's why from employee, this employee table will be given alias as emp. And we currently in this scenario we have seen that okay, left join is enough. So left join again the same table employee, because we have just one table and we are also naming it as mgr. So this emp table is a alias of employee table only, and currently this will be treated as left table. And again we have same employee table with a different name called mgr, and this will be our right table. So we are performing a left join, and this is our left table and this is our right table. So query starts from here. So from we know that okay, this is now emp, so that's why we are extracting the emp dot full name, and if we have manager, that's why we are extracting mgr dot full name. Okay, now you understood how the flow works. Okay, cool. Now what is the connecting link between both the table? On this one, emp dot manager id, emp dot manager id is equals to this one, manager dot employee id, mgr dot employee id. Cool. So this is how the query will look like. Now let's try to break down like what will let's try to make a dry run on this query. Okay, so we need two columns. First one will be employee, because we are using some alias. If we will not use alias, so it will be emp.fullname, and in place of manager it will be manager.fullname. Okay, now we are doing left join. So every row of left table will be there, the result. So it's jd, js, ab, jd, js, ab, bw, ec. If we have forgotten what is left join, so every row of left table will be in the result set, and the common elements from right table will be included in the result set, and the columns which are having no values will be filled with null value. Okay, so that's why first step we have included all the elements of left table. Now see, JD is having employee manager ID is null, and can you find null in this column? No. So this will be filled as null only. By default null, both are like similar kind of, but we don't have this value, that's why we are putting null, we are not putting this null. Okay, then let's go to this one. JS manager ID is 1. Okay, 1 is there, so it is a common element, and whose employee ID is 1, it's JD, so we will add JD here. Okay, then AB, the manager ID of AB is 1, and 1 is the employee ID of JD, so we will add JD, the common elements. Then same for 2. 2 is for JS, we'll add JS here. 3, 3 is also common, and it is for AB, so we will add AB. Okay, cool. So if you can see this result and this result, it's matching. So now you can ask me a question. Is it's compulsory to use left join? No, it's not compulsory. You can use right join, inner join, whatever join you want. Okay, you can use any join, but this for this scenario, this join seems perfect to me. Okay, so that's all about self join. I have tried my best to explain you with simpler examples. Most of the people don't show this part, the breaking of the tables, that where people get confused. So I have also shown you, so that I tried my best to explain you what actually self join is. Okay, now let's see what is actually cross join. Cross join is not very tough kind of, and I will try to wrap up as soon as possible. Okay, so it is actually Cartesian product, and I think we have seen the Cartesian product in inner join part. So each row of one table will be paired up with each row of another table. Okay, so it is used to find all possible combinations. Okay, so let's suppose we have one table as employee, and we have employee ID and full name. We are taking two rows, JD and JS. We have another table as department, and we have department ID and department name. Okay, so department ID is 101, this is 102, and it is HR, and it is IT. Okay, now if we have to show full name and department name. Now you might be thinking, why I'm always showing full name and department name? Is it compulsory? No, it's not compulsory. You can show anything, employee ID, department ID, it's your wish. But do you think if I show department ID instead of department name, will it make any sense? No, because who knows what is 101, what is 102, what is 103, 4, 5. But everyone knows, okay, it is HR, it is IT. So they know the name. So that's why for the need of this lecture is to show this, but maybe in your work you have to show different columns. Okay, so whatever you want to show, it should be added in the select column. Okay, select clause. So full name first will be JD, and this JD will be paired with both the rows HR and ID. JD will be paired with HR and as well as ID. Then we have JS, it will be also paired with both. JS will be HR and ID. So this is how it works. So we have to, each row of this table will be paired with each row of another table. Okay, now how will the query look like? Select, So we have to show the full name, which is from EMP table. This table is named as EMP, and this table is named department. Okay. So EMP dot full name, then department dot department code name from EMP cross join department. As simple as that. Okay. So when you will run this, you will get this. I'm not showing the practical of it because it's very simple. Just if you want to practical this, you have to create a table. I have already shown you how to create a table, how to insert the data. This is the easiest one because you don't have to create two tables. You don't have to create a foreign key and all. It's just one table, and just you have to run this query. Sorry. Just you have to run this query and you will get the answer. The understanding is more important here also. Just you have to create this table. You have to insert two rows. This table, just create two rows and you can run this query. So understanding is more important instead of just showing everything and showing redundant things and making the video very long. Already my videos are quite long. Okay. I hope you understood this part. So that's all. Where we basically use cross join. So whenever we have to generate test data or generate pair comparisons, we can use cross join. Okay. So that's it. We have seen a lot of things in the joins, like starting from inner join, left join, right join, left and right join are also called as left outer join, right outer join. We have also seen full outer join, full join, and then we have seen self join with the easiest way, and also we have seen cross join. Okay. What next you can learn once you are done with joins and you feel confident in join? So what's next? Okay, this is also important because I should give you a path. So what you should follow next, or if you want from me, I can create video on it. Okay, but maybe if you want to try it on your own, you can also multiple joins in one query. Okay, so currently we are seeing just one join in one query, so you can practice multiple joins in one query. Then joins with aggregate function. Okay, this is also you can try. If you don't know about aggregate function, we have already created a video on it. Then subquery with joins. So I haven't teached, I haven't taught like subqueries till now. So in next video, I'm going to cover subqueries. So maybe once it will be completed, also we can have a video on subqueries with joins, or if you need, we can create a video, or otherwise you can also practice by your own. Then you can also explore performance optimization uh, with joins, because it's not like we have to just make any kind of join and we have to extract the data. It should be also in the least possible time. The time complexity should be also less. Okay. Then one more we can think like handling null values in joins also it's important. So these are the some like 4 to 5 topics that you can consider after exploring and after having a good command in joins. And if you need, I can also create videos on each of these topics and we can practice some questions with better examples. But maybe if you want, I can create a video, otherwise you can also do it on your own. So that's it. We have covered a lot of things, and maybe uh, I have tried my best to explain you what actually joins is with some examples, with practical examples, with breaking the examples into um, like the atomic form. And if you like this video, please just give it a thumbs up. It encourages me to create long videos and to um, give you the best content. Okay, not just by hearting the queries, instead explaining how the queries are working, how the things are working on the back end and all things. So if you like it, please give it a thumbs up. And if you have any doubt, anything, please add in the comment section. Thank you. Meet you in the next video. In next video, we are going to see subqueries. So that's all. Meet you in the next video. Till then, bye bye.